Okay, so this mini lecture is going to look at states of charge. We are going to define 3 different states of charge. So when we talk about charged particles and charged objects, we're going to define their state of charge in one of 3 ways. The first way is that an object could have a neutral charge. A neutral charge tells us there is no charge. It has a charge state of 0. Another option for a charged state is a positively charged object. So an object can have a positive charge. And finally, we can have an object with a negative charge. All right, so where do these 3 charge states come from? Well, they come from atoms. Atoms make up all states of matter, right? So these 3 charge states come from our atoms. And if we think back to our first introduction to atoms, we know that there are particles in atoms that have charge states of a similar nature. So if I think about the atom, well, a neutral particle within the atom, we know, is called a neutron. And there's a positively charged particle within atoms. Those are called protons. And of course, there's also those negatively charged particles in an atom, and those are called electrons. So if I have a neutral object, a positive object, or a negative object, it has to do with these charged particles that are within an atom. We also have to know that protons and electrons actually carry the same magnitude of charge. So they're very similar in that they both carry the same charge amount. The charge, I'm going to use the lowercase q, of an electron and the charge of a proton both have magnitude equal to 1.6 times 10 to the minus 19th coulomb. A coulomb is our unit for charge, and we use the capital letter C. So if I have a neutral object, it tells me that the number of protons and the number of electrons are canceling each other out. They're the same charge value for the protons as the electrons, and I have the same number of protons as I do electrons, and so the number of protons, which equals the number of electrons, the net charge, if I add up all that charge, it goes to 0. Well, what about a positively charged object? If I have a positively charged object, that means the charge contribution from the protons is bigger than the charge contribution from the electrons within that object. I have more protons than I do electrons. All right. What about a negatively charged object? Well, a negatively charged object tells me that the contribution to the charge from the electrons is greater than the contribution of the charge from the protons, which makes it so that the number of protons is less than the number of electrons in that object. So charged objects are simply a state of how many electrons we have compared to the number of protons we have. If they're equal, I have a neutral charge. If the number of protons is greater than the number of electrons, I have a positively charged object. And if the number of electrons is greater than the number of protons, I have a negatively charged object. So how do I get these different charge states? Well, I have to change the balance between the protons and the electrons. And we do that by moving electrons. Why electrons? Well, why electrons goes back to sort of how an atom is constructed. And we're going to kind of review that real quick. We're going to look at the Bohr model of an atom in order to do that, to simplify it. So in the Bohr model of an atom, we have a nucleus, and inside that nucleus are both protons and neutrons. So we have our neutrons inside that nucleus, and we have our protons inside that nucleus. And they are really stuck together. They are really tightly bound inside that nucleus. Surrounding that nucleus is an electron cloud in different orbital shapes. Here's our most simple electron cloud. Surrounding that is the electrons, our negatively charged particle, and they're free to move. They're free to be moved out of that space and flow through different spaces. They're loosely bound to this nucleus. So for through various manipulation methods, we can move those electrons, thereby changing the overall number of electrons within an object that's made up of all of these atoms. We can't do that with the protons and the neutrons. They're really, really tightly bound. So we move electrons from one object to another to either get a positively charged object or a negatively charged object. Removal of those electrons is in a very specific manner. Electron movement, changing the electrons, moving them from one object to another, happens in a quantized way. What do we mean by that? Well, we mean that very specific numbers of electrons, specific number of electrons make up the charged state of the object. I can't move half of an electron. I can only move whole electrons. And so specific numbers of electrons are moved between objects. Furthermore, we don't lose any electrons as we move them from one object to another. And this leads to the idea of conservation of charge. Also important as we think of charged particles. And in that conservation of charge, there's no loss or gain of electrons as they move from one object to another. So we're able to move objects, change the number of electrons, move electrons, change the number of electrons between one object and another. And as we take electrons off of one object, we now have fewer electrons than we do protons in that object, and that object becomes positively charged. As we move those electrons and put them onto another object, we have more electrons than we do protons on that second object, and that object becomes negatively charged. And it's done in very fixed amounts, very specific numbers of electrons are moved without any loss or gain. So that's how we get our different states of charges, our different object states with respect to charge: neutral, positive, and negative. All right, good job.